Sorry about that, guys. My camera stopped videoing. Okay, 72 divided by 12. Who remembers what that is? 12 fits into 72 6 times. Okay, so 72 divided by 12 equals 6. We can get rid of this divided by 12 and this 72 and rewrite the whole problem to make it look a little clearer. So now we have n plus 3 equals 6. Notice how this problem looks a lot simpler than the original one. Okay, let's keep going. Now, our next step is number 5, addition or add. Is there any addition in this problem? Oh, ding, 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 ding. There it is. You found it. Now, we've already said we cannot add a numerical value to an unknown variable. We can't do it. But what we can do is get the unknown variable alone so that we can find out what it equals. And this is what we do. Instead of adding 3 to n, we're going to subtract 3 from both sides. So now, n, because this cancels out, equals 6 minus 3, which is what? 3. And what do you know? Look, we have our whole answer in plain sight. N equals 3. Alright, I know that may have been a little bit confusing for us because I got cut off, but if you have any questions, you're always welcome to come back and ask, okay? And before we finish, I want to let you know that the last step of PEMDAS is subtraction. Subtract. Okay? In case you were curious about that. Let's move down just a little bit. Okay, you see here, question 2 and 3 under review. You are required to write those down on a blank sheet of paper and get those done, alright? Okay, I know you can do it. Let's look now at our new concept, and I say new rather loosely because we have gone over these terms several times in class, and I'm pretty sure you guys know them by heart by now. However, we are going to jump back into geometry, but we're going to do a lot more hands-on work, so I'm going to make sure you are brushed up on the basics, okay guys? So let's go over what each idea and model look like. Okay, here's the ideas. Okay, the names of each model is called the idea. And then I am going to show you what this idea looks like in plain sight. Okay, so we'll have the ideas here and the models on this side. Okay? A point. What does a point look like in geometry? It's simple. A point is a point just like anywhere else. That is your point. Looks like a period. Okay? What about line segment? Your line segment is a line with 2 points on each end. That means it has a stopping point on each end. Okay, that's a line segment. What about a regular line? Okay, just line, nothing else. A line does not have points on the end. And actually, when you see it, it might have 2 arrows on each end because that means it never ends. It's a continuous line, okay? That is a line, and that is what the model of a line would look like. How about ray? I know Eliana is going to get this one right. A ray is a point and then a line. Now, it doesn't have to go any specific way, but one end has to have a point and one end would have an arrow. Okay? How about angle? What do you think an angle would look like? An angle is two rays put together, actually. So they have a matching point. Their points connect, and there's two lines. So there's two, I apologize, there's two rays connected by one point, and their arrows go different ways. Okay, that would be an angle. Now let's look over here. We have our ideas still, and we're going to draw our models on this side. What about congruent angles? Sorry guys, I am just moving this all over the place. Alright, what about congruent angles? Congruent angles are pretty much identical, okay? All that means is they are identical. So if I draw an angle that looks like this, oh, sorry, that's just not big enough. Let's make it bigger. If I drew an angle that looks like this, a congruent angle would be one that looks the exact same. The same height, the same width apart. Miss Breeze's drawing skills are less than spectacular, so that might not be the best example, but congruent angles are identical, okay? What about intersecting lines? I think Joelle was really great about getting this one right every time we reviewed it. Intersecting lines are lines, remember no point, that cross each other. Okay? They are continuous lines that cross each other at any point. Perpendicular lines. Perpendicular lines are a little funny, and I know, I really do apologize. Maybe next time I'll take this down. I know when we're talking about perpendicular lines, almost every single time the class knew what it was, but we would always say it kind of funny because it's a big word, right? So this is what a perpendicular line would look like. They go in opposite directions, okay? One is a line and one is actually a ray because it has a stopping point, notice. Okay? We have a line connected to a ray. That is a perpendicular line, and they are pointing in opposite directions. They are opposite. Okay? And lastly, the last idea we're going to go over and give a model for is the parallel lines. Parallel lines, they never intersect. Okay? One might be over here, and one might be over here. Those are parallel lines. You might see another example, and I'm actually going to do it on this side, so make sure you're paying attention. There might be another example of parallel lines where they are directly underneath each other. I know this is what our cards show us when we reviewed them in class, right? Those are directly above each other. They don't have to be directly above each other. They just have to never be able to cross, like the perpendicular lines or the intersecting lines, okay? That is what a parallel line is. Now, your job or your work for today, for your new concept, is to write down these ideas and the models correctly on a blank sheet of paper. Okay? You are to rewrite the ideas and the models next to it on a blank sheet of paper. Now, remember, this is mandatory. Okay? Your review work here. And today your work is to rewrite these ideas and models. Okay? You get 25 points for this section and 25 points for this section. If you don't do them, you do get marked off for it. So make sure you are working diligently. You guys have been phenomenal. Thank you so much. And I know you guys will excel tremendously in geometry, and I'm really excited to see what you guys do. Anyway, have a good day, and we'll talk again tomorrow.